Nice to meet you. I'm Khatar Choktai and you're watching my YouTube channel, School of Advanced Chemistry. I'm going to solve question number 2, May-June 2023, 5-3 variant. Let's get started. Question number 2, a student plans to study the rate of hydrolysis of 2-bromo-2-methylpropane. As the concentration of 2-bromo-2-methylpropane decreases during the reaction, the concentration of hydrogen ion increases. This one. The student plans the following method. Step number 1, place 100 centimeter cube mixture of propanone and water into the conical flask. Heat mixture to 35 degrees Celsius to maintain this temperature Add 1 centimeter cube of 2-bromo-2-methylpropane to the mixture and start timing. After 1 minute, transfer 10 centimeter cube sample of the reaction mixture into conical flask containing ice and 4 drop of methyl orange indicator. Step 5, immediately titrate 10 centimeter cube of the reaction mixture with 0.02 mole per dm cube sodium hydroxide. Step number 6, repeat sampling and titrating at a regular time interval over a total time of 45 minutes. Heat the reaction mixture to 50 degrees Celsius. Remove the final sample and titrate this. State the apparatus you would use to maintain the temperature of the reaction, this one. So here we are going to use electric heater. So electric heater or water bath. There are the two basic major main equipment. Thermostat, water bath. Number 2, suggest why experiment is carried out away from the neck flame, because these chemicals are highly flammable. There are flammable chemicals. B part, state the piece of equipment and their capabilities that you would use to. Number 1, measure 1 centimeter cube of 2-bromo-2-methylpropane in step 3. So whenever you are going to measure 1 centimeter cube or in centimeter cube in fractions, fraction volume, then you will use burette. Next thing, transfer a 10 centimeter cube sample of a mixture in step 4. Now you want to transfer 10 centimeter cube sample. So for 10 centimeter cube or for 25 centimeter cube, you will use pipette. That is volumetric pipette. So once again, for 10 centimeter cube solution transfer and for 25 centimeter cube solution transfer, we will use pipette, because there are two types of pipettes. One can measure accurately 10 centimeter cube and other one, the traditional one, is going to measure 25 centimeter cube. C part, explain why the reaction mixture is transferred into conical flask containing ice. The basic purpose of ice is, here in step 4, basically after 1 minute, we are going to transfer the sample, the conical flask, and we are adding ice. So the basic purpose of ice is to decrease the temperature, to quench the reaction, to reduce the rate of reaction basically. So basically we are going to stop the reaction or to decrease the rate of a chemical reaction. To stop the further reaction, to decrease the rate of reaction immediately. Next one, state the measured dependent variable in this experiment. Dependent variable is the result of the experiment that is going to be changed because of our activity. as a result of our activity. So which one is the dependent variable for this reaction? That is volume of sodium hydroxide solution used in titration. Volume of NaOH, sodium hydroxide. Student record the result. V final is the final titer volume, 47.25 centimeter cube in step 1. Complete table 2.1 by calculating V final minus Vt, and here is the column and it is for 1 mark. Number 1, here V final, I mean overall value is this one, and Vt is equal to this one. So 47.25 minus 1.25, that is equal to 46.0. Next one is similarly 39.50, 29.50, 27.50, 23.00, 18.85, 16.10, 9.25, and here is 0.00. The titer Vt is proportional to the concentration of the hydrogen ion. State what V final minus Vt is proportional to. So basically, this is directly proportional to the concentration of 2-bromo-2-methyl propane. Directly proportional to the concentration of 2-bromo-2-methyl propane. As we are going to increase the concentration of 2-methyl 2-bromopropane, this answer will be increased. If we are going to decrease the concentration of this one, then definitely this answer will be decreased. So final volume minus volume titer of the titer, that the difference is going to be dependent on the concentration of 2-bromo-2-methyl propane, that is given over here. This one, the basic major main reactant lying over here. As initially he is saying, the concentration of this one is going to decrease. During the reaction, the concentration of H ion increases. So basic thing is this one. If you are going to decrease the concentration, obviously there will be less concentration of positive ion, and the volume difference between V final and V titer will also be low or difference. Plot a graph on the grid show relationship between V final minus V time and time. Use a cross to plot each data point. Draw a curved line for the best fit. So that is the line of the best fit, or best fit curve, I mean. And I think this is an anomalous point. Circle the point on the graph you consider to be anomalous, and here it is. This is an anomalous point. And next thing, suggest one reason why this anomaly may have occurred during this experimental procedure. So basically, it means that reaction was not fully finished, not completely finished at that time. Reaction was not completely finished. At that time. That's why there is an anomalous point. I mean, basically, let's see over here, this point may be correctly at this position, or it may be at this position. It is highly likely to be occur that it should be at this position. So the wrong reading is basically V final minus V tighter. So why this answer is going to be wrong basically. In fact that the concentration, as I told you, this answer is directly proportional to the concentration of the reactant. So it means that at that time reaction was not fully finished, and this value is as compared to this, it is less over here. So concentration is going to be less. If we take this reading at a correct position, then at that time it seemed that its volume difference is going to be higher. I mean, the concentration will be higher, should be higher, if the point is going to be at correct position. If this point is going to be at this position, concentration of 2-bromo-2-methylpropanone should be higher. But overall, now the experimental answer is this one. What is the reason for that? Because when we check the reactions, when we take the reading at that time, the reaction was not fully quenched. Use the graph to find two half-life for this reaction. State coordinate of the both point you use in this calculation. So first half-life, number one, I'm using this one line, this one coordinate initially, and if I'm going to half it this one, or I can extrapolate this line as well. So basically from here I can see that half of the one coordinate is this one. Second half-life, that will be again having the one coordinate same, that is 24.20, and its half will be equal to obviously its half, 12.10. So where is the 12.10? Here is 11 and 12.10 almost here. 11:40 almost. It's 11:40. Use your answers. State the order of reaction with respect to 2-bromo-2-methylpropene and explain your answer. There is the first order basically because half-lives are constant. Half-lives are constant. That's all about this paper. Thank you very much. Thank you very much. Good day, good night. Bye.